This video is brought to you by mywayteaching.com.
Let us see another illustration, that is stopping distance of vehicles. When brakes are applied to a moving vehicle, the distance it travels before stopping is called as stopping distance. Okay, so when brakes are applied suddenly to a moving vehicle, what is the distance traveled by that vehicle up to that point? So that is called as stopping distance. It is an important factor for road safety, and it depends on the initial velocity v naught and the braking capacity, or we can say deceleration, that is minus a, that is caused by the braking. So derive an expression for stopping distance of a vehicle in terms of v naught and a. So now we should derive an expression for the stopping distance of a vehicle in terms of V naught and A. So let us see. Let the distance traveled by the vehicle before it stops be ds. Okay, distance traveled by the vehicle Okay, distance traveled by the vehicle before it stops is ds. Then using the equation of motion, that is v square is equal to v naught square plus 2ax, and we know that v, that is equal to 0, and we have the stopping distance ds is given by, yes, instead of this x, we are replacing it with ds. We'll get the stopping distance as minus v naught square by 2a. Okay. Thus, the stopping distance is proportional to the squares of the initial velocity. Doubling the initial velocity increases the stopping distance by a factor 4, isn't it? If we double the initial velocity by 2, then the squaring term is there, isn't it? So it increases the stopping by a distance by a factor 4. For the car of a particular make, the braking distance was found to be 10 meter, 20 meter, 34 meter, 50 meter, corresponding to velocities of 11, 15, and 20, and even 25 meter per second, which are nearly consistent with the above formula. Stopping distance is a very important factor considered in setting speed limits, for example, in school zones. Okay, it is a very important factor. Now, let us see what is this reaction time. When a situation demands our immediate action, it takes some time before we really respond, isn't it? Reaction time is the time a person takes to observe, think, and act. So, reaction time is nothing but the time which is taken by a person to just observe, think, and then act. For example, if a person is driving and suddenly a boy appears on the road, then the time elapsed before he slams the brakes of the car is the reaction time. Reaction time depends on complexity of the situation, isn't it? Suddenly if that boy comes, he should apply brake, isn't it? So that is reaction. So this reaction time, it also depends on the complexity of the situation, and it also depends on an individual. You can measure your reaction time by a simple experiment. Take a ruler and ask your friend to drop it vertically through the gap between your thumb and forefinger. After you catch it, find the distance d traveled by the ruler. In a particular case, d was found to be 21 centimeter. Then estimate the reaction time. So you just take a, yeah, ruler. You can see here, you just take a ruler and ask your friend to drop it vertically, and it should pass through your the gap between your thumb and forefinger. Okay, then you just calculate the distance d after you catch it. The ruler drops under free fall, isn't it? It is a free fall. So for a free fall, we know v naught is 0, and we can take acceleration as minus g. It is given by minus 9.8 meter per second square. The distance traveled d and the reaction time t are related by the distance traveled d and the reaction time. This is a reaction time. They are related by the equation that is given by d is equal to minus 1 by 2 g t square. Okay, we know how we got this equation, isn't it? Yes, using the equations of motion. So in this case, we want this reaction time. So let us take this to this side. 2d minus g t square, and this minus g will take it here. Then we'll get 2d by minus g, and if we take this reaction time without considering the negativity, 2d by g seconds is the reaction time. So if in the question for a particular case, we know the reaction time is given as 21.0 centimeter and g is 9.8 meter per second square. So the reaction time is given by d is 21. We should convert it into meters. So it is 10 raised to minus 2, and g is 9.8. It is given by zero point 0.2 seconds. So it is called as reaction time, which is taken by a person in this particular case to observe, think, and act. Now let us study the concept of relative velocity. You must be familiar with the experience of traveling in a train and being overtaken by another train moving in the same direction as you are. Okay. Well, that train must be traveling faster than you to be able to pass you. It does seem slower to you than it would be to someone standing on the ground and watching both the trains. Okay, the train which is passing near to you, it seems very slower to you than it would be to someone who is standing on the ground and who is watching both the trains. So, in case both the trains have the same velocity with respect to ground, then to you the other train would seem to be not moving at all. So, to understand such observations, we introduce the concept called as relative velocity. Okay, the speed of the train which is near to you when you're sitting in another train, that is different, so it will look different for you and as well as for the person who is standing outside the train, means who is standing on the ground and who is observing both the trains. So it is relative to a particular thing. So for that, in order to understand those situations, we are introducing a concept called as relative velocity. You just consider two objects A and B moving uniformly with average velocities VA and VB in one dimension, say along x axis. So you just consider two objects, that is A and B. So they are moving with velocity VA and VB in one dimension, say along x axis. If xa naught and xb naught are the positions of objects A and B, xa naught and xb naught are the positions of the object, then these xa naught and xb naught are the positions of the object A and B at the time t is equal to 0. Okay. Their positions xa of t and xb of t at the time t are given by. So their position, that is xa of t as well as xb of t at the time t are given by. So here the initial position is xa of 0 plus velocity they are moving with va and time t. And similarly this one is xb of 0 plus velocity bb of t. Then the displacement from object A to object B is given by. This is position of object B and position of object A. Now let us consider the distance between object B to A, that is xba of t is given by, yes, that is xb of t minus xa of t. We know xb of t and even we know xa of t, isn't it? So substituting that, we get xb of t as xb of 0, xa of 0 plus we get vb minus va of t. So this equation C is easily interpreted. It tells us, as seen from object A, object B has a velocity Vb minus Va, because the displacement from A to B changes steadily by the amount VB minus VA in each unit of time. So we say that the velocity of object B relative to object A is VB minus VA. So if the velocity of object B relative to the velocity of object A is given as VB minus VA, similarly the velocity of object A relative to the velocity of object B is given as VA minus VB.